All right, this is part 2 of our lesson 9.4. Let's hope I have the right one here. Calculating equivalent fractions. And if we take a look at your step in, it says Kuma wanted to figure out an equivalent fraction for 5, 6. She drew this picture to help. Think for a moment, why did she draw that picture? The one that you're looking at here in your book. Hopefully you've got your book out at this point. And you're probably saying, hopefully, that the fraction bar has been divided into how many equal pieces? 6, right? That's our denominator. And how many of those pieces did she color in? 5, that's our numerator. And so she drew that, that picture to represent 5, 6. And she's trying to find a fraction that's equivalent to 5, 6. So equivalent means equal to, right? So we have another fraction bar that she drew. And in this one, what she did is she drew a horizontal line right through the center. And she realized when she did that, it was like, whoa, I found an equivalent fraction. Think about what that equivalent fraction is that she found. And if you're looking at it going, okay, this was 1, 2, 3, 4, 5, 6. This is double 6, so 6 times 2 is 12. So here's 12. So this is now 12ths. And how many of those pieces are going to be colored? Well, it's going to be 10 of them, because this had 5 of them, so 5 doubled is 10. So 10 twelfths is going to be equivalent. So she noticed that displaying the shape that way would double the value of the denominator. Right? The denominator was 5 here. It was 6 here. My bad. And they doubled it, and it was 12. And we also doubled the value of the numerator, correct? This is what happened to it. Doubled it. That's important to know, because as we're going into this, whatever you do to the numerator, you have to do the denominator. Whatever you do to the denominator, you need to do to the numerator. And that's something that we need to keep thinking about. So here's how Kuma thought about it, right? We had 5, 6. And what did she put here? She wanted to double it. So we'd put, if you're just saying 2, you're absolutely right. And if she did that to the top, she has to do it to the bottom. So this would be 10. 6 times 2 is 12. So 10 12, see the equal sign right here, is equivalent to 5, 6, or 5, 6 is equivalent to 10 12. So it's just really handy, because it's hard to find equivalent fractions when we're dealing with different denominators. How did the total number of parts change when we did that? Well, we figured that out, right? The total number of parts changed. They doubled. Right? We have 10, and we also had 12. And did the total area that was shaded, did it change? Did this blue area change when she did cut it in half? Hopefully you're saying no, it's exactly the same, right? And that's why those two fractions are equivalent. The denominators, what do we notice about these denominators? So if we look at 6 and we look at 12, because that's our other denominator, when you look at that, you're probably thinking, well, 6 is a factor of 12, right? And 12 is in the counting pattern of 6. So that's something interesting, right? That 12 can, or 6 can be a factor of 12, and we can multiply 6 and get 12. And that's what they're saying here. 12 is a multiple of 6. All right, again, if you have any questions about the lesson today as you're working through, make sure that you join us for office hours, and I can help you there. Or that really is the best way to do it. Then make sure that you post your answers onto Class Dojo with a picture that says that you got it or that you're still working on it. I had a few students who circled some of the problems that they had issues with, which was great. I could look at them. Try to make sure that your pictures are clear. I know your cameras aren't awesome, but if you have lots of light and hold it close enough, we can probably see your work. All right. Enjoy lesson 9.3.